So today I'm gonna talk about my term project of automatic control subject. First I'm gonna explain how I obtain all model with Simscape. First you're gonna click to this link called ctms.engine.umich.edu and then you're gonna see this control tutorial for MATLAB and Simulink. Then you click to the topic that you gonna create the Simscape model. First one is the cruise control, and you will see the Simscape button like this. Click for it and you will see the setup here, the parameter, how to create the new model. First thing you're gonna need to download the Simscape multibody library, which is the add-on of MATLAB application. Click right here and search for it, then download. And next you gonna read this and scroll down to the bottom of the page. You can download the final Simscape model that has been created right here. You click the link and it will download the Simscape model like this and the subsystem like this. Next you're gonna adjust the value of the mass to match with the value that have given in the assignment, which mine is the 1300, and then adjust the damping coefficient and then adjust the design speed. Next you're gonna click run and then it will show the output like this and this, which is the vertical speed and vertical position graph. Next you're gonna do the next topic, which is motor speed. Same as the cruise control, you gonna read the setup, study the parameter, learn how to create the model and scroll down to the bottom of this page. Then download the final Simscape model right here, and then you will get the Simscape model like this and the subsystem like this, and you're gonna adjust some parameter value to match with the value that given in the assignment individually, and you will get this output. Next is the motor position. Same as cruise control and motor speed, you gonna read the setup, the parameter, the how to create model and scroll down to the bottom. Then you download the final Simscape model right here and you get the Simscape model like this, the subsystem like this. Also adjust the value to match with the value that given in the assignment, and then you're gonna get the output like this. Next one is the aircraft pitch. Unfortunately, we don't see the Simscape model here, so I can only do the Simulink part, which have model like this, and you're gonna change the parameter to match with the value that have given in the assignment, and you click on this box, the state space box parameter, and you enter the value right here. You will get output like this. And next, I'm gonna explain how to apply the control system designer to design the PID controller. Compare the base control system in time domain, LULOCUS, and Bode diagram. So you go to the same website and click to the topic that you're gonna design the controller. Click the PID button and reading this model parameter, the overview, and then you scroll down to the proportional control. You will copy this value and you put it in a MATLAB and change the variable that match with your assignment, and then you type control system designer and put this value in the bracket. Then you're gonna click the run on the live editor and click the PID tuner on the apps tab. It will show the PID tuner and the control system designer. First, you're gonna go to the PID tuner to find the right response time which match with the requirement that given in the assignment, which is the setting time, overshoot, and steady state error percent. And if you find the right, once you find the right response time, you're gonna go to the control system designer window and you gonna click this to put the design requirement, and you go to the PID tuning, and then you will adjust the PID tuning response time to match with the response time that we get before from the PID tuner, and then it will show you the LULOCUS graph and Bode diagram plot and the step response like here. And it's go the same for the PI value. You have to change the parameter to the PI type in the tuner, and then you get the response time, and then you put it in the control system designer like before, and you will get this value. And then this graph, same go for the PD and the PID. Here is the summary of cruise control controller. As you can see, this is the type of controller: P, PI, PD, and PID. P, PI, and PD pass all the requirement, which is setting time, overshoot, and steady state error, but the PID didn't pass the overshoot and steady state error. So the base system that you wanna use in the cruise control controller is the P, PI, and PD. Then the motor speed control system designer. You also go to the website and select motor speed, reading for the contents in motor speed PID controller design, and then you gonna download the value to the MATLAB, and you gonna see this graph like this. And you're gonna adjust the response time first. Use the right response time at the control system designer. Same go with PI, PD, and PID. And then you're gonna see that the P is not past the overshoot requirement, but the other is passing all the requirement. So the base system that we can use in this motor speed controller is the PI, PD, and PID. And then for the motor position, you're gonna reading all of this, copy this value and place it in the MATLAB and adjust the value to match with the value that given in the assignment, and you will run it and you will get control system designer of the motor position. Like this one is the P and PI PD motor position, PID, and here is the summary of the motor position controller. As you can see, the type of P and PI is not past setting time, and PI is not past the setting time and steady state error. So you're gonna use the PD and PID which pass all the requirement, and it sets the base for the motor position controller. Finally is the aircraft pitch PID control system designer. You go to the website, click at aircraft pitch, click PID, and scroll down to the proportional control. You're gonna see detail of this. Paste the code in the MATLAB application like this. And you will get the graph. Adjust the response time first and place it in the control system designer. You will get this graph of P, PI, PD, and PID. Then you're gonna get the graph with the table here, which is the summary of aircraft pitch controller. As you can see, the PI and PID is not past all the requirement, and PD and P is past all the requirement, which mean the base controller of the aircraft pitch is the P and PD. Thank you for your attention.